So picking up where we left off, we can set the mass. So the parts that we want it to be zero mass, so this link number 4 right here. So if we look at the mass of that, set that equal to 0.01. Okay, 0.01 pounds. SolidWorks doesn't like it if you try to set a mass to 0, so I just set it to something low. And again, the center, you can control this, where the location of the center of mass is, but since these are symmetrical parts, it's in the right spot. Okay, so the Fourbar is set up, and I just have concentric constraints here. You don't have to worry about, I have these surfaces mated, but this is really two-dimensional motion, so it should simulate properly. And the angle right here, so that was set to 47.2 as the problem indicated, and I can right-click on that and suppress it so that we can observe the motion here. And you can see that it actually is Grashof. But there are a couple of toggle points, right? This is lined up. This could go, you can see if you try to move this, it's not sure which way it's going to go, right? It could go this way, or it could go that way. And then there's another toggle point here. So if you're driving this on, it's not clear which way, if you try to come back, this could actually go this way, or it could come this way. And this is not in a very good position right here in terms of stability. So in terms of overall design, if you wanted to be stable right here, this isn't the kind of linkage it's set up. But anyways, I'll turn off that, I'll unsuppress that. And now if we want to simulate this, I'm just going to switch to motion study, and I already had that one set up, but let me just do a new motion study to show you how you would do it. So first of all, under the mates, you would suppress you have it in the right starting spot, but you want to suppress that angle because you want to be able to drive it. And then I would put in a motor, make sure that this is turned on to motion analysis. You may have to go to tools and then add-ins and make sure you turn on the SolidWorks motion add-in. Okay, and so now we'd put a motor, and so I'm going to put a motor on link 2, and it will be a constant RPM motor. I just want to run it very slowly so I can watch what the torque requirement is going to work out to be. So make that 0.01 RPM, and it's going in the direction that I want it to go. So I'll accept that, and let's see, I'm going to raise this up, and I'm just going to simulate it for 1 second. So I'll move that bar back there, and now we want to put in a plot here. So I'm going to pick on the plot button, and I'll select forces, and then motor torque, and I need to select the motor. Okay. Select the value. I have to select what I want to output there. So it's the Z component of torque, right? This is XY, so the Z component is what I want, and that will give me the sign as well. Okay, so now if we run the simulation, and you can see that I'm getting 0 inch-pounds, 0 inch-pounds, and that's because I probably didn't set the gravity properly. So if I click on the gravity button, you can see that the gravity is coming in the Z direction, so it's not going to affect the object at all. I'm going to have to stop here and pick up from the next video.